Hi guys, in this video I cover the concept of the queue data structure. A queue is a specialized linked list in that values are always appended at the end of the list and they are removed from the beginning of the list. In terms of queue, we talk about enqueue and dequeue operations. So values are enqueued at the end of the queue and they are dequeued at the beginning of the queue. A queue is a Fifo data structure. Fifo stands for first in, first out. That means the first item that is added to the queue will be the first item that's taken out of the queue. Initially, a queue is empty, so its size is 0. And as we append or enqueue values, the queue grows. And as we dequeue values, the queue shrinks. Now, the most important functions are enqueue and dequeue. Enqueue takes a given value and appends it at the end of the queue. The dequeue operation simply takes the very first value, if there is any, at the front of the queue and returns it and removes the value from the queue. There could be additional functions such as isEmpty that checks if the queue is empty, or peek. Peek would take the very first value in the queue, return it without removing it from the queue. Now, how do we implement a queue? Essentially, you can just implement a linked list, but you reduce the functions that operate on that list. Initially, there is a head pointer that points to the very first node, and as we add values, additional nodes are added. As we remove values, we delete nodes from the beginning of the list. So an enqueue operation always results in an additional node with a value, and a dequeue operation removes the head node in the list. So let's take a look at an example. Here's a queue. The queue has a head pointer, which I just call queue. So the head pointer points to null. If I say I want to enqueue 3, I create a new node with the value 3. Then if I call enqueue 5, I iterate over this list to the end and then create a new node with 5 at the end. If I do enqueue 6, I do it again. I always append at the end for every enqueue operation. Now dequeue always takes the value of the head node and removes the head node. In this case, it would be 3. So 3 is removed and then 5 and 6 are left. If I call dequeue again, 5 is removed and only 6 is left. If I call enqueue 3, 3 is always appended at the end. So enqueue always adds nodes at the end. Dequeue always takes the very first node, returns the value and removes the node. Now what is the time complexity? So enqueue would be O(n), dequeue would be 1, peek would be 1, isEmpty would be 1. Clear could be 1, but essentially it would be O(n) if we consider that we have to delete and free up all the memory. Now, how can we improve the enqueue operation? What we can do is we could have 2 pointers, a head pointer that points to the very first node and a tail pointer that points to the last node in the queue. So the head pointer would be just used for the dequeue operation. We check if a node exists. If so, we update the head pointer and return the value of that node. The tail pointer would be used for the enqueue operation, where we just go to the last node, we create a new node, update the next pointer of the last node to the new node. So to recap, a queue is just a linked list. Internally, it will use a head pointer for the dequeue operation and a tail pointer for the enqueue operation. We don't provide additional functions such as get by index, or add or insert. There's really just enqueue at the end and dequeue from the front. I hope you enjoyed this video. Thank you for watching.